Alright, these are some thoughts and opinions on the VFC HK417 Gearbox. Now, there's what I've been reading. Very many people have some quite strong opinions of this gearbox, but I'm gonna go into detail about many of those things that seem to bother people, including me as well. And the most known one is the strength of the front part of the gearbox here. This is actually the newest version that they have made. They made some changes. They added some reinforcement at the top here. They added this bar here. This side as well, this smaller bar. The first ones didn't have these bars here, so it was just this thin top bar here. So the upper part was extremely thin, and they were breaking off like nothing. So they added these little bars here. Now this, I don't know, maybe that increases the wall thickness about maybe 20 to 30, or the cut volume of the front part here, maybe from 20 to 30% more. So that helps a little bit, but this bottom part as well, as you can see, they have done some attempt to round or radius these corners, but that seems to have failed. I think that has the opposite effect that it should have. Also here, but interestingly not on the top here. So I will be definitely doing some reducing there. And to add on this top part here, the gearbox had this metal part here that is it focusing? Yeah. This front part of this metal piece would hook on this front, and the hook on this end would hook on this. And I think this is like this is silly, because this really isn't doing what they think, or I think what it's supposed to do is basically hold these shell together a little bit, and maybe possibly also absorbing some of the shock on the front part of the gearbox. But I think what they should be doing is just, instead of having this metal part here, is to just cast it solid, so that this part wouldn't be needed. So then you would have more material, it would be more rigid, so you wouldn't need that side support, and then it would be stronger on this front part, so it wouldn't crack as easily. And then when it has more material, you could even maybe add a little screw here or somewhere here, more on the rear, to keep the gearbox closed, so that it won't start opening, because actually in some high operated guns the gearbox can actually start splitting here slightly on some version 3 gearboxes. So, but that's not very common, but it would be still good to have one more screw here, just to have the gearbox shut like in all of its corners, so that like you can see here, it has there is some space between the, kind of fit my fingernail. But yeah, that's about that. And then oh, this lower part here, it's lacking the slight thickening part here that is featured on every normal version 2 gearbox. Like this is the gearbox from this is a Lonex gearbox. It has that thickened part there. This gearbox is missing that, and there is actually no reason for that I could find. Let me show. Now, here's the magazine, and these lips here extend so far up that it's actually coming this close to the gearbox. But as you can see, there's this much space here. You could add almost 2 millimeters of material thickness on both sides here. So I don't know why it's not there, but they could just increase the wall thickness here so it wouldn't crack as easily. But that's one suggestion if there is any VFC engineers watching this. And it's not like it's even contacting the the lower receiver either, so there's really no reason to keep these prods so thin. But anyway, another complaint I've been hearing is this trigger mag, because it's different from a normal version 2 gearbox. But personally, I wouldn't, or actually people argue why this isn't good is because then they cannot use the spectre and whatever inside the gearbox MOSFET systems. But personally I wouldn't care less for those, because I prefer having just a mechanical switch, because they are very reliable, and then just have the MOSFET as a separate part. But that's just my personal preference. But I understand why people are complaining. But I still think that this design here seems to be well thought. I haven't opened this yet, but this cutoff lever seems to be quite beefy, and I don't think it will break anytime soon. So this is actually quite interesting to have the cutoff lever outside the gearbox. Like in normal version 2 gearboxes, the cutoff lever is on the inside. So here I guess you can do some internal work without opening the gearbox, the switch and the cutoff lever. Here's actually the selector plate. This right here. It's actually steel, so it's not gonna break unless you bend it somehow. I think this is quite cleverly made, because I think their plan was to make the gearbox as thin as possible, so that they could reduce the thickness of the lower receiver to realistic dimensions. So it seems to work. On the far right, it's on safety. This right about here blocks the trigger, the rear. That's semi and full auto, so you can actually test the cutoff action here. So, and also the space for the wiring. Now for the exclusion of this part here, there seems to be very much room for thick wiring. As you can see here, you could fit a 12 gauge wiring there, or maybe 14 gauge. That's already, or maybe 12 gauge as well. That's way overkill, but there is room for 16 gauge and in my opinion that's, you don't really need that any thicker than that. So excluding this part here, I guess you could dremel this slightly wider here, but that's not a big problem. And also it seems that maybe you could even fit a MOSFET here. I have to check the lower receiver later before I can say that, but I'm still thinking whatever. So this is customer's gun. I'm gonna install a MOSFET and do some tuning and maybe change some parts here. So I still haven't decided where I'm gonna put the MOSFET. It's probably gonna be in the buffer tube, but I'm gonna check all the places that are possible. And then this is also a good thing that they have this rear screw to hold the spring guide in place, so that it won't start wobbling around. Because if you have a wobbly spring guide, it could you could break your spring or cause jams and stuff. So it's good that they include it there. And also I think this is the one of the main reasons why people are hating on this gearbox is this weird split design. This part here actually comes off so I'm now actually opening this for the first time. Oh, that sound is coming from the renovation. This building that I live in is under some outside renovation, so there is some noise here. So anyway, I hope you can hear me, but so this is the way that can disassemble it. I don't get why this is like this, but I still have to open the gearbox and do some thinking that what could be the benefits and cons for having this split design, but so far I think this is completely useless. I guess you can see the gears well, and it's easier to shim. No, these gears are looking weird. It could be that the gear ratio is different from the usual, but I will open this up and continue. Oh, also these connectors here, the wiring is quite thin, but any upgrader would probably replace them anyway. But these connectors here are actually quite good. They are extremely tight, so I'm thinking there wasn't any power loss here, and the gun was missing a fuse. That's not good. You always need a fuse, no matter what setup you have. So I'm gonna just open up the gearbox and stuff. So here I have the gearbox open now, and for my surprise, I'm actually quite liking most of the things I'm seeing here. Where should I start? Here is the spring and spring guide. Now this is completely made of steel. It's completely solid steel with a 4mm hole, so you can actually use a screwdriver when opening the gearbox, so that's a good thing. So indeed it's a full steel one with bearings, and slightly thicker at the bottom here, so I don't think this will be breaking anytime soon. This is great. And so in fact the gearbox uses normal version 2 gearbox spring guides, and possibly, yeah, you could fit a version 6 if you really want, if you shorten tabs, but no point doing that. But anyway, where's the spring? This is on M100 or M110 roughly, and quite interesting to note here, the spring gets thinner at the end, so that way there is no way of the end of the spring slipping off the bearing and cause a jam, because sometimes if you have a too loose spring or too thin spring guide, you can actually have your spring going over the other side, so then you could have a jam between the piston, inside of the piston walls, and these bearings. So I guess that's a good thing, but it's just an M100, so and the gears, they are VFC auto shimming gears. What I'm gonna do is I'm gonna remove these springy things and just put a brass sleeve here and shim it like normal. But here's the gear. Check the gear. It's made of steel, sintered steel with a reinforced release tooth there, so that's a good thing. And a sector clip. It's a really thin sector clip though, but that shouldn't be a problem. And the spur gear, really nice and thick, but it's injured, so it's good. As well with this one, I'm gonna remove the auto shimming and shim it like they are supposed to be shimmed. The bevel gear, nothing special here. And anti-reversal latch. This is a normal version 2, but the spring is different. So you could use a different brand cutoff lever. No, not cutoff lever. An entire reversal latch. But you have to use the spring or bend the normal spring to fit. And the shaft here at the top seems to be rather short, so possibly you need to shorten an aftermarket one slightly, but that's not a problem. The rest, the upper part of the gearbox components are all version 2 M4 spec, so that's a really good thing that they didn't decide to make everything proprietary. So here we have a polycarbonate piston and an aluminum piston head. So I'm gonna be replacing this aluminum piston head with something a bit lighter, so because these aluminum ones tend to pound your gearbox into smithereens. Or, well, the difference isn't really that huge because it's just a weight difference, but still plastic absorbs impacts better than metal ones. So, and the piston material, I guess for stock piston polycarbonate is alright, but for upgrading purposes I wouldn't use polycarbonate because, well, it's not flat out bad, but it's just a wrong material choice for a mechanical component. The right choices are glass fiber reinforced nylon, as known as polyamide 6 or 6.6, and then polyacetal copolymer or homopolymer. So yeah, for stock piston I guess it's alright. The design is very similar to a D-Boy stock one. The pickup tooth specifically, is this even focusing here? It's focusing on the bottom. So there's the pickup tooth. As you can see, there are 2 bubbles inside. That's not a huge issue, but you don't want bubbles. And the cylinder is made of steel, so it's not just chromed brass, it's actually steel. But too bad, the porting is too far forward here for the barrel length, so it needs to be replaced. For M120 levels you need, the barrel length is about 350 millimeters, so you need the one with the hole pretty near in the back to get a correct volume. Unless you're using really heavy BBs, then you could just use a full cylinder, but that's maybe over voluming already. And the nozzle, I like this one. It's made of polyacetol, as known as POM. Now POM stands for polyoxymethylene, and that's the same as polyacetol. Polyacetol is just a more commonly used name. So anyway, I like how they have extended the part here so that the O-ring actually sits on the thick part instead of being at the same place with the groove here. So that way because in many aftermarket nozzles the O-ring is located right under the groove here, so then the material thickness is really thin. So then in some cases even I have experienced a nozzle failure where it breaks around the ear. So it's good that they did that, and also this thing seals really well. I'm going to demonstrate soon. So here's the cylinder head. It's a plastic one. I guess plastic is good considering the gearbox, so plastic will absorb more energy, but I'm gonna put some sorbethane on it anyway, so it's really tight fit, so I can still get it off, hopefully. Yeah, it has a damper, slightly softer than most stock ones, but it's nothing like sorbethane, so I have to put some sorbo there. So I'm just quickly gonna demonstrate the seal or the tablet first. The tablet plate is also made of polycarbonate. Nothing special. It does its job. So this is, by the way, the correct way of checking your air seal is, you must keep your nozzle at the forward position. And then, well, this is my technique, but to have a correct test, you have to take into account the position of the nozzle instead of just pressing at the bottom, because then it will seal better. So you must keep it at the forward position. So if there is a leak on the O-ring, then you will notice it like this. Now I already cleaned these, so they don't have that much grease, so there's a bit of friction here, but still the seal is. And when it passes the port is quite far forward, so it gets right over here. But when I press it forward, it doesn't really go anywhere, so I cannot feel any leaks. So this is actually maybe the best stock seal I have ever witnessed. So that's good, I guess. Well, I guess that's good. But some parts are gonna be changed anyway here. So this isn't stay in stock. Probably the piston head and maybe the piston, we'll see. And then the bushings they're nicely actually, they're properly fixed in their places, so they aren't like loose or coming off in any way. I don't know how, maybe they're just tight fit, or then they have been glued in, but they aren't going anywhere. I think I'm seeing some glue there. Yeah, there is some glue there. I'm not sure if you can actually see it, but I really love this macro zoom of the online camera. So anyway, and then the holes for the axles are actually the proper size instead of being too loose like almost every brand. So there is absolutely none, almost none play, like well, there's no shims here now, but like the axles aren't moving sideways at all, and if the pushing hardness is anywhere near it's supposed to be, these are great bushings. Also maybe the best stock bushings I have seen, if they turn out to have the correct hardness so that they can actually last, like those G&G brass bushings, or commonly called copper bushings or brass bushings, but they're actually bronze. They're bushing bronze material and they are made way too soft, so they actually wear out, but these are steel, so this will be better. Is that everything? Oh, the little weird part here. I'm still not sure what's the point of this. I guess it makes the shimming of the gun much easier, and setting the pinion to bevel, because you can actually keep the motor, put all the motors in here and screw this fixed here, so then you can I guess you could, well, I will find out when I'm gonna shim this, but so we can just keep this here and then just kinda see how it's meshing. I don't know, but I think this is just, I don't get it. I guess it's alright, but no need for anything like this. I guess it's good that the hole for the motor is a one piece instead of being split like in normal gearboxes. But I guess there is still a more chance of a misalignment when you have, instead of having two parts, you have three parts. So if something is off, everything is off. So one interesting thing to note, the cutoff lever actually doesn't have a spring here anywhere. The spring is fixed on the switch assembly here. The spring right here. And interestingly, this switch trolley spring is actually being hooked on one of the screws that hold the gearbox together, so that's interesting, but I guess it works. And also it seems that I'm not 100% sure because I haven't opened this, but it seems to me that the switch trolley is exactly like in version 2 switches, so you can replace it if you want to, I believe, but don't take my word. What's the point anyway if this works? I believe this is gonna work just fine. just fine. By the way, here is a hole for some receiver tab or pin, but there actually wasn't a pin here, so maybe it's just a remain of some prototype phase design, and they just haven't removed it from the final design. But yeah. And oh, here's the hub-up unit. I'm really liking this. It's plastic, but it's still, the design is really good. There's a lot. It has these steps, so it's easier to adjust. The overall length of the adjustment isn't very long, but it seems that this chamber is really good, are really well compatible with ear hubs. You can extend the window really well there, so that's good for considering that. So here's the piston. I took the piston head off and found something interesting here. But first I'm gonna explain a little better my statement that polycarbonate is the incorrect material choice for a piston. And well, basically right now I'm studying plastics engineering in a university, so I'm not claiming that I'm an expert on plastics, but I know a great deal of plastics, and polycarbonate is a good plastic for like well, safety goggles and anything that needs to absorb a lot of impacts. But one thing that polycarbonate isn't good at is handling dynamic loads, and then also its friction properties are much worse than nylons or POM, so you need to use a lot of lubrication. But the problem is that polycarbonate can't handle chemicals even nearly as well as nylon or POM, so there are actually many lubricants that actually harm polycarbonate, which will make it brittle, and eventually they could break. So, and also polycarbonate is much more sensitive for sharp corners in a geometry. For instance, here you can see that there is some sharp corners there. And also polycarbonate under dynamic loads and high stress, continuous stress, prolonged stress, it starts to form microscopic cracks in it, and eventually those will continue and cause a failure. And I noticed here when I took the piston head off, it was torqued on really tight, and I can actually see some cracks already here. I'm sure that these could be too small to be seen on this camera, but you can see those they tend to reflect light differently on different angles, so you can see them. And that's just because the piston head was so tight on. So just from that, it has these cracks here, and I'm sure after many thousand shots, this would probably break off, because one of the cracks would continue larger and then crack completely off. So I guess polycarbonate is so often chosen for the piston material because of its impact handling capabilities, but that's the only thing that it's slightly better than nylon or POM. But that's, in my opinion, that's nearly not enough, because you need dynamic load handling capabilities and good friction properties and good wear resistant. Like polycarbonate doesn't resist like mechanical loads, and like metal gears, for example, it needs much more lube on the teeth profiles to not wear. So, and where was I going? I guess this also, it shouldn't matter because it's a mechanical component. Well, the appearance, because well, you can make from polycarbonate a really cool looking part like this, transparent, and of course polycarbonate sounds really cool. Sounds much cooler than nylon or POM, but still. So basically, if you're wondering what pistons are polycarbonate and what are not, all these transparent ones are always polycarbonate, because nylon and POM, they cannot be transparent because of their the polymer chains in them. They organize in a, they create like crystals in a microscopic scale, so it reflects light. So you can have really thin like nylon film that is somewhat transparent, but when you start to increase the thickness, it becomes non-transparent, like white or milk-ish color. So if you have an even partially transparent piston, it's very likely polycarbonate. And also those non-colored nylon pistons, they tend to be yellowish to white depending on the exact type of the nylon, but like most Chinese stock pistons are always like those yellowish color. They are always nylon, or not always, but those yellowish white ones, they are nylon with glass fiber reinforcement. And that glass fiber thing, just to clarify, it's not like those glass fiber sheets that you can build stuff off with epoxy. Glass fibers in a plastic, it's like cut into really short, like much less than half of a millimeter long fibers, and it's actually mixed in the material itself. So that way, yeah, it stiffens the plastic a lot, and other things I could list, but